Welcome to the REM User Guide, Video 2. In this video we will show how to use the tool to calculate emissions. From the landing page, navigate to the emissions input page using the sidebar menu. Populating the inputs in the standard input options panel allows us to perform a simple run. The first input field is the project name, which for this example I will set as User Guide Video 2. This input field does allow the use of spaces and special characters. However, since it is used by the tool to give a file name for any downloads, it's good practice to keep the project name descriptive but suitably concise. The next input is emission year. Years between 2018 and 2050 can be selected. The emission year defines the fleet database which the tool uses. More information on this is provided in the tool user guide. The next input is the fleet mix selection, where the options are either default or advanced. This input accompanies the traffic data input file, which is selected and will be referred to in more detail when we get to the traffic data input. Next is the pollutants input field. There are 7 options here. 3 local air quality pollutants, those are NOx, PM10 and PM2.5, and 4 greenhouse gas pollutants, CO2, CH4, N2O and CO2e. Users can select any combination of these pollutants. The next input is the traffic data input field, which needs to be uploaded into the REM. A blank template can be accessed via the downloads page under guides and templates. Here we have the default traffic template and the advanced traffic template. I can open these in any program which can read a CSV file. The advanced input template has an example row already in it. The fields here are total car flow, and within those we have different fuel types for cars, total LGV flow, again within those different fuel types for LGVs, and total HDV flow with different fuel types again. We have speeds for LDVs and HDVs, and then some other parameters which are explained in the user guide. The default template is more simplified, where we only have total LDV flow, total HDV flow, and then the remaining column headings are the same, so LDV speed, HDV speed, road type, county, link type and link length. Again, these are discussed in more detail in the user guide. Heading back to the tool, if we input a traffic data input file that I've set up for this example, once the file is within the tool, 2 buttons are generated, one to clear the traffic template, put that back in, and the other to preview it. And what we can see in this pop-up modal box is those same column headings from the CSV file we just looked at, but they're populated with link data. The final input option for the standard input options panel is the include catalyst fails checkbox. This is explained in detail in the tool user guide. Essentially, having the checkbox ticked allows the tool to account for newer engine types which have engine abatement which no longer works. The emissions of these engines are therefore assumed to be comparable to the generation of engine which didn't have the abatement fitted as standard. At this point, we have all the information we need to perform a run in the REM tool. Clicking the Run Emissions Calculation button takes us to the emissions output page where we can see the results. The first tab is the annual total emissions, where we have emissions for each county. Next is the annual total TII emissions, which is a similar format, but it refers to those links which are defined as TII in our traffic input file, whereas total is other plus TII, so total is everything essentially. Next is the detailed emission breakdown, which is pollutants on a link-by-link basis. We could download these tables in the Downloads menu under the Outputs option here. We get a pop-up box for the detailed emissions output table just to let us know that it will be downloaded with the units that were specified in the emissions output page. We can change this and then go back to downloads to download in that different metric format. We can refine this run where we've used the REM tool to calculate emissions by using some advanced input options in the emissions input page. The REM tool has 6 input options here. These are fleet database selection, origin data selection, Euroclass selection, receptor file input, bus flow input, and batch file facility. The receptor file input option will be discussed in the next video, where we show how to use the REM tool to calculate concentrations of local pollutants at receptors. The batch file facility can be used for the calculation emissions use case. However, I won't show it in this video. We've got a separate video on use of the batch file facility. In the fleet database selection box, we have 3 options. The tool's default is to use business as usual. A description of each of the 3 fleet databases is provided in the full user guide. In the origin data selection box, the origin fleet dataset is a matrix of values which estimates for each county the portion of traffic originating from each county and is based on the national transport model. The data can be viewed by hitting the download button. Here we can see that for TII owned road links in Carlow, it is estimated that 44% of that traffic originates from Carlow, with the remainder coming from surrounding counties. The next box is the Euroclass selection. This feature allows users to remove Euro types from the tool's calculation. This may be used, for example, if a vehicle exclusion zone is required to be modelled. In practical terms, the tool removes the relevant vehicles from each fuel type and body/engine size from the fleet and reassigns them based on the remaining Euro type categories. Selecting these options will remove those Euro engine types from the fleet. So when we run a new calculation, we'd expect emissions to be smaller since we've removed the older and more polluting engines from the fleet. The next advanced input option we're going to discuss is the bus flow input. Bus flows are not captured within fleet databases discussed previously. This is because the Eurotype engines of Irish bus fleets are not easily available on a county or national scale. To allow users to include emissions from buses, however, we've included a bus flow input module, as shown on screen. This comprises a traffic input file for which the layout is similar to the normal traffic input file. I'll put a bus traffic input file into this session here, and we can preview it, and we can see the column headers are largely similar to the traffic input file. A template for this bus traffic input file is available under Downloads, Guides and Templates here. The next item which we're required to fill out is the Euro category table. The table has 2 columns which users are required to fill out. These are categories pertinent to the NOx emissions and Euro categories pertinent to PM10/CO2 emissions. The reason for these 2 separate columns is that it allows users to include catalyst fails if required, which can be independent of one another because of different types of abatement. I'll put in some dummy data now. In each case, the two columns must total 1. The final thing to include in this bus flow input box is to check the include bus emissions during run. Now we can click the Run Emissions Calculation button again, and we'll be taken to the Outputs homepage. As we've seen before, each tab contains a different format of data, and these are available for download in the Downloads Outputs page here. Finally, the other download feature, which was not discussed earlier in this video, is the source apportionment box. Source apportionment is the term to describe the source of emissions by vehicle characteristic. Emissions output can be calculated and apportioned by each vehicle Euro class, each vehicle fuel type, each vehicle engine size / weight category, or any combination of the three. In this example, I'll include the fuel type and the engine size / weight class, and I'll download the annual total data. This calculation takes a little bit longer to perform because we have an emission concentration for each pollutant, and then vehicles within that pollutant split by fuel type and engine size / weight in this example. If we look at the output file, we can see each column has a pollutant type, a fuel type, an engine size or weight within that fuel and pollutant category.